Okay, sorry. I wanted to make sure I turned the messages off so I wouldn't get any coming in. All right, while we're doing this. All right, problem 17. And I've got to be perfectly honest with you. The answer is 208 meters. Okay, I think I had it. The original correct answer is 120 meters. I have no idea where I got that. I think I know what happened. I forgot to multiply the last factor by mg, which came out to be, so it came out to be 119.6 or something like that. But it's actually going to stretch 208 meters. All right, and here's why. There's a couple ways to think about it. Okay, so first of all, what we're actually doing is, let's take a look at this. We're actually figuring out how far, with k is equal to 11.83 or whatever it was. I think we'll go with 11.83 newtons per meter. How far, if you're going to stand up here and jump off a cliff, how far can you go if you have 150 feet of rope, 150 meters of rope? All right, of the rope before it starts to, and then you're going to get this XF right here, which is how far it's going to stretch. Now, what's going to happen is you're going to have this huge velocity right here. What's going to be your velocity at this point before the rope starts stretching? Well, that's easy. We know that the final velocity, anytime we're in free fall, by now we should know is 2g times the initial height, which in this case is 150 meters up to here. That's how far he's fallen. And that comes out to be about 54.25. But the nice thing about this is we can just leave this, okay, and say, all right, well, that's going to be our initial velocity at this point, and we're going to figure out how far this is going to stretch, so our energy before is going to equal our energy after. All right, and here's what we're going to do: is our energy before is we got a 1/2 mv naught squared plus this gravitational mg x final is equal to 1/2 k x final squared. Something kind of cool happens here when we do this 1/2 times 70 times, now what's this squared? It says 2gh. So we put in 2 times 9.8 times 150 plus 70 times 9.8 times x final is equal to 1/2 k x final squared. So we make the quadratic equation, put this on this side, put this on this side, and we've got this. We've got 1/2 k x final squared minus 70 times 9.8 times x final. That's our b term, minus 1/2 of 70 times 2 times 9.8 times 150. And that actually comes out to be, this is 1/2 times 11.83 times xf squared minus 686 xf minus 102,900 joules is equal to 0. Got a quadratic equation for xf here. I don't care. I'd go to my quadratic solver, plug in my values, and I get the positive number I get is 208 meters is how far that thing's going to stretch, or about 209. I gave you plus or minus 20. All right? Okay, knock yourselves out. Have fun with that.